Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and you are just stuck with me today for today's episode. Today I'm going to be talking about parasitic draws on vehicles, or more specifically the vehicle batteries. I've had a recent stretch of parasitic draws that have really been kicking shops' butts lately, and so I thought it would be a good opportunity to talk about it. Of course, this is nothing new. There's been parasitic draws on vehicles as long as they've had batteries and ignition switches to get the vehicle to a point where we don't want current being drawn out of the battery, or we want a very small amount of current being drawn out of the battery so it doesn't die while it's sitting and not in use. Well, of course, that is exactly what constitutes parasitic draw, is when we have excessive current draw out of the battery to the point where it kills the battery while the vehicle is not in service. Okay, so nothing new there. I'm pretty sure everybody listening to this is fully aware of what a parasitic draw is and has dealt with one more than once. But there are some tips and pointers and a little bit of a process I've got here that I wanted to share with everybody. Again, just some of the things I talk about on the podcast, or the case studies that I like to bring up, it's when I see shops struggling with it on a consistent basis. And it's kind of weird how sometimes you can get jobs in waves. What I mean by that is you'll see the same or similar thing several times within a short period of time. And I've always experienced this in my career, different things. You know, I'd have 5-6 GM trucks come in with failed fuel pumps within a couple weeks span, you know, and then I wouldn't see any for 2 months afterwards. It's just, and I don't know, maybe there's some bad gas in that area, but, you kind of see jobs come in waves in this industry for whatever reason. And anyways, I've had a number of parasitic draws recently. So I wanted to share my tips and my process, how I approach parasitic draw, because unless they're really intermittent, I think these things are all findable without a whole lot of effort, maybe some time and a little bit of patience. But other than that, we can find these things. So first thing I wanted to mention about this is a lot of the things that went into building my own process for parasitic draws was learned through going to training and attending events where they talk about these sort of things, and I built them all into my process. So I can't take credit for everything that I do here. This was all constructed, you know, through my own personal experiences, but also what other people have taught me. So the message there is go get some training, go to these events. You know, there's lots of online stuff as well, but go to some training and it's going to help you build your process for whatever you're doing, including a parasitic draw. And again, a parasitic draw is nothing new. I've been doing this since I started in this field. And I remember when I was taught to do it with a test light. So one of the technicians at the very first shop that I worked at would disconnect the negative battery terminal and put a test light in series to the battery. So they put one end of the test light on the actual negative terminal of the battery, and they put the other end of the test light on the battery cable, which was disconnected from the battery. And if that test light lit up, it meant that you had a draw in the system that was going to kill the battery. And your goal was to pull fuses and disconnect things until that light went out. And that was effective on older vehicles. It worked pretty well. As long as you could see that bulb and that test light, you could unplug fuses and disconnect stuff till it went out, and then you'd probably find the component. Well, there's very few computers on these vehicles, very few control modules on these vehicles that I'm referencing. So that method worked, but not for long. Eventually, you got to vehicles that had a number of control modules on them. And what would happen is, regardless of the draw, you'd connect the test light in series that way, and the test light would just blink. And it would just keep blinking and keep blinking. And you could get it to go out by unplugging whatever control module was causing that test light to blink. So the more effective way was to put your ammeter, you have your multimeter, you can measure volts, ohms, amps, set it to the amp function, and then put that in series. Of course, you had to be careful here because if you flip the ignition switch on or trip the door switch and the amperage went over what the fuse in your meter was rated at, it would pop the fuse in your meter. And so we went through some fuses figuring that stuff out early on. That was the progression there. And that's what I did for a number of years, was just an ammeter in place. And then I would still unplug fuses. I would yank the fuses one by one until I watched the draw on my ammeter drop down to an acceptable level. Okay. Again, I've grown from that. I don't use that method anymore, but that was my traditional method for finding a parasitic draw on a vehicle. And, of course, cars have advanced and our testing methods need to advance along with them. So that's kind of what I'll be talking about today, is what is my current method of tracking down a parasitic draw? How do we do this efficiently without air and without wasting a whole lot of time too? That's the other thing. This can be time consuming. Even if you're doing it right, let's not waste any more than we need to. So again, I'm going to go through kind of a process here of how I approach a parasitic draw when I get called out to a shop for, they've been dealing with it, or occasionally they don't even want to mess with it. They just don't have the time. They don't want to dig into it. And they'll just have me start fresh. And I guess I'd almost prefer that in most cases, but a lot of the times, and especially lately, shops already tried to fix it. And maybe they have called me in to program a control module. It's usually something like a BCM or a cluster, program the module, and then the draw is still there. And okay, well, now can you help us figure this out? Because we're really in the weeds at this point. Okay, well, but I have a process on how I'm going to approach this either way. I have a few questions up front for either the customer of the vehicle or the shop who can get into contact with the customer of the vehicle. So I got 3 questions here that I'm going to ask right off the bat just to get an idea of what I'm dealing with. Number 1, how fast is this draw killing the battery, right? So if you have a fully charged battery and you just let the vehicle sit, how long does it take for the battery to die? And this is going to help me gauge what the size of the draw is before I even connect to the vehicle. And it will also kind of, depending again on the speed that it kills the battery, it's going to give me an idea of what size draw that I'm looking for here, which will change the components I'm looking at depending on the size of the draw from the battery. Along with this, I want to know if the battery that is installed in the vehicle right now, as we're about to jump into this vehicle, is this a good battery that is fully charged, meaning that can, this battery pass a load test, or has it been depleted so many times by this draw that it's completely worthless? And of course, is the battery fully charged at the moment, or has this thing been sitting out back dead for 2 days? Again, might change my approach a little bit, but I want to start with a fully charged, known good battery before I actually do the diagnosis. So I may get with a shop and say, hey, let's get a good battery in this thing before we proceed. But I want to know, how long does it take to kill a battery if it's in good shape and fully charged? The battery that's in there, is it any good? Do we need to change this? Do we need to approach that first? And it's always good to start with a fresh battery anyways, because there are occasions where the battery itself could be the problem. Hopefully a shop would be able to identify that, not always. Heck, even dual battery setups, I see that on the trucks up here. You could have one battery that's dead and one battery that is functional and working correctly, and the dead battery, or you could say bad battery, however you want to term it, could actually drain power from the good one. I've seen that before. The cause of a parasitic draw was one of the two batteries under the hood. And so the fix was replacing the battery. So again, I always want to know the condition of the battery. Have they been tested? Should we test them, find out, and let's get a good battery in here before we proceed. And then the final question I have, and I don't always get the direct upfront answer here, but I'm going to ask it anyways. Is there any aftermarket accessories installed in the vehicle? This could be something like a remote start or security system that's hardwired under the dash, but it could also be something that's plugged into one of the auxiliary power ports, like a GPS or a cell phone charger or any other aftermarket accessory you could think of that would plug into one of those ports. These can obviously cause unwanted draws on the system, so we want to be aware of that, and that, again, might be the fix. Again, a lot of times shops will be able to find these, but it's questions that I want to just get out of the way before I proceed. And if it's something under the dash, like a remote start or something like that, I may just unplug that thing as one of my first tries to see if that's going to get rid of the draw, because I have nothing but trouble with aftermarket components that are wired in under the dash, the remote starts and the anti-theft systems that are not originally equipped on the vehicle seem to be nothing but trouble. And so they can cause other problems beyond a parasitic draw, but that is definitely one of them. All right. So once I've got that out of the way, I've got those questions asked to the customer, whether that be the shop, driver of the vehicle. My next step is kind of asking myself some questions about the vehicle as I'm jumping in. First one, I should at this point have just at least an idea of the kind of amperage draw I'm dealing with. Now, this may just be a guess. I might be wildly inaccurate, totally understandable. But based off of what I've asked them about how long the vehicle takes to die, what's the condition of the battery, assuming that it is a functional battery, how long is it taking to kill it? I already have an idea before I hook up to the vehicle what kind of draw that I'm looking for. And we'll talk about why that matters as we proceed here, but I like to just have an idea before I jump in of what I'm after. And again, I might be wrong. I might be taking the information in incorrectly, or I may not have gotten the correct or all of the information. It happens. But again, I like to have an idea. And what I mean by this is is this a 3, 5, 6, 8 amp draw on the system that's killing the battery pretty quickly? Or is this a 200 milliamp draw that's taking 2 or 3 days to kill the battery, right? It's going to change my approach, and it's going to change what's necessary in order to find the draw on the system as well. And again, I'll explain a little bit more as I go, but one of the things I'm thinking at this point before I actually jump on the vehicle is what kind of draw do I think that I'm going to be looking for here? Now I need to find out, before I really jump into this, how long does it normally take this vehicle to completely go to sleep to the point where we are at our base draw on the battery, meaning that there is going to be some draw on any automotive battery to keep memory systems alive on the vehicle. Now, what is this number? What's good? 50 to 80 milliamps is what I usually shoot for. Generally it's under 60 on most vehicles, but there's a lot of different vehicles out there, so you can have a lot of different acceptable draws. But really, that 100 milliamps is kind of my cutoff. If I see it above 100 milliamps, okay, let's find this, let's correct this. If it's below 100 milliamps, well, now I need to question, is this an intermittent issue, or is there something else going on here where a customer is doing something that's causing the draw intermittently? You can pursue that in other ways by actually talking with the driver of the vehicle. But anyways, I want to know, how long does it take the vehicle to get to the point of that normal, acceptable draw under normal circumstances? So the reason I need to know this is some vehicles take quite some time to fully go to sleep to get to that base normal draw. And this is where it ties in with what size draw do I think I'm after? And here's why. Let me explain this. If you're looking for a 150 milliamp draw, something that takes maybe several days to kill the battery while it's just sitting there not being used, that you're going to want to wait that full time period, which in some cases can be 40 to 50 minutes on some vehicles, for everything to fully go to sleep before you can really assess the draw on that battery. But let's say the battery's dying within a day or overnight because it's a 2 to 3 amp draw. Well, you can wait that 40 minutes if you want. You don't have to. I'm telling you right now, if that draw is over an amp, you absolutely do not have to wait the full 40 minutes or 50 minutes for the car to go to sleep. You could wait 10 minutes, honestly, probably even less, and that car should be well below an amp of draw. Now, I'm sure there's exceptions out there. I'm sure there's vehicles that will prove me wrong on that. Hey, I'm happy to hear about it if you got an example. But from my experience, within 5 to 10 minutes of just letting a vehicle sit, you're going to be below an amp of current draw from that battery. Again, I'm sure there's exceptions to it, but I see it on a lot of vehicles where they will drop below that point relatively quickly, not fully asleep. Again, there could be things awake. There could be things happening. If you're trying to get down to that 50 to 60 milliamp draw, you may have to wait that full time, whatever that is, close to an hour. But if you're looking for a 2 to 3 amp draw, you can do this within minutes. You don't have to wait that full amount of time. That system should drop below that 1 amp range relatively quickly on just about everything that I've worked on. This all ties in again with what size draw am I dealing with? How fast is this normally killing the battery? Because that's going to change my approach and maybe even how I tell the shop to set up the vehicle for me. If I feel like I'm going to be chasing a small draw, I'll have them set it up where, and I'll give you some of the details for the setup, but where it's already been sitting for an hour before I even get to it. But if I feel like this is a larger draw that I'm dealing with, I know I'm going to be able to assess it quickly without waiting. And so I don't bother with it at that point. So again, that's where the questions asked up front kind of will change my direction. Now, I still might have to hook up to the vehicle to get an idea of what I'm dealing with, but I always want to ask those questions up front to put my best foot forward in a parasitic draw, because we don't want to be sitting around for 40 to 50 minutes if we don't have to. Of course, if you're in a shop, you could be doing other things at that point. Mobile, I don't exactly have that option. So I have to approach this with some thought so that I'm not wasting a ton of time. The last thing here that I ask myself, try to remind myself of, is that some vehicles you can connect a scan tool and go into the special functions of whatever control module is the power mode master for the vehicle. This is usually a body control module, maybe some sort of power distribution center, whatever vehicle is in charge of distributing power to the vehicle. Some vehicles will have an option through the scan tool for you to go in and run a special function to basically power down the vehicle, or to bring it to its asleep state, if you will. And this is through a button in the scan tool. You hit it, power down vehicle system or power down electrical system. There's different names for it. The two that come to mind right now, I've seen this on GM vehicles through the body control module, and I've also seen this on BMWs as well. So again, special function through the scan tool, you're forcing the vehicle to go to its powered down state without waiting that time period. So if you have that function, if that's an option for you on the vehicle you're working on, this will save you all kinds of time, especially if you're dealing with that really small draw and you don't want to wait that 40 to 50 minutes. I remember the first time I dealt with a small draw on a vehicle where I had to wait for it to go to sleep. It was on a Ford Windstar, and it ended up being aftermarket trailer wiring that was causing it. But it was such a pain, and I had such a hard time wrapping my head around that I couldn't test anything for 40 minutes because that's the time it took the vehicle to go to sleep normally. But if you get a scan tool function to make that happen, use it. So it may be worthwhile to hook a scan tool up to the vehicle and see, okay, is this an option? Do I have this function, this capability on this particular vehicle? Save myself a little bit of time here. Okay, so let's talk about getting the vehicle set up to actually do some measurements and to try to track down where this draw is. First thing I'm going to have is all the doors, the trunk, and the hood in the open position. One of the main reasons is I'm going to need to get to components, right? You're going to need to get to components inside the vehicle, but I'm also going to need to access the battery. And that could be in the trunk, could be under the hood, but you can also have power distribution centers under the hood, in the vehicle, in the trunk area. So I want all that stuff open. Now, of course, if you open the doors, the trunk, the hood, you're going to trigger switches that are going to keep things awake, keep lights on, keep modules talking, all that stuff. So we're going to trip all the switches, whether those be in the door latches, the trunk latch, the hood latch. Sometimes in the door jambs, those ones are a little trickier. You may have to physically jump those in order to convince the vehicle that the door is not open. But whatever is necessary to make the vehicle think that all the doors, the trunk, and the hood are closed, but to actually have them in the open position. Again, so we can access components while the vehicle is asleep. We can get in there and test stuff and make measurements without disturbing anything, without opening a door and resetting the process, right? Because that's one of the worst things that can happen is if you've waited the time for the vehicle to go to sleep and then you wake everything up, now you've got to wait that 40 to 50 minutes again. And that's extremely time consuming, again, especially if you're doing a mobile job. If it's a proximity key vehicle, make sure that the key or keys, and that's a question to ask, is does the customer have all of their keys accounted for, right? Did they lose a key within the vehicle? But on these proximity vehicles, we want to make sure that the key or keys are not in the vehicle while we're trying to do this, right? A key just being present within the vehicle can wake up a lot of systems, cause systems to draw power that we don't want to. So let's make sure we have the keys accounted for and out of the vehicle. We're going to move them several feet away from the vehicle so that they're not setting off any proximity systems in order to enable modules to draw power from the battery when we don't want it. One other thing here too, you may or may not have your scan tool connected here. Now, a lot of times I won't have my scan tool connected because your scan tool itself, depending on the VCI, can draw some power just by itself. It could also potentially keep some networks awake and modules talking, so we want to avoid that. Now, the exception might be is if you're using that scan tool in order to force a power down, like I just mentioned, you may have your scan tool connected, but that really is going to depend on the vehicle. And most of the time, I don't have my scan tool connected when I'm getting the vehicle set up to check for a draw. All right. So that's my setup on vehicles. And I may request to the shop that this is done in a cool area, meaning that it's not sitting out in the sun. I'll get to why that could be useful as we proceed forwards, but that may be a request of mine that it's in the shop or that it's not in the sun when you leave it sit here in this position ready for me to check it out. All right, now before we jump into the testing process here, one thing I will note, and again, for the most part, shops are pretty good at identifying stuff like this, but this is a good point to just give the vehicle a good visual and audible check. And so what I mean by that is hopefully your shop or wherever the vehicle is quiet enough that you can just stick your head in the vehicle or around the vehicle and just listen for anything that's happening. Okay, listen for any clicks, buzzing, humming, electrical noises, anything like that. Give it a visual, see if any lights are on. I mean, this is all pretty basic stuff, and I understand that, but I found a number of parasitic draws just by using my ears and listening for a click or a buzz or a hum or some, electrical motor that's moving, and I was able to identify the component without really any detailed testing. I just followed the noise that I heard until I found the component. I had a seat cover on one recently that was pulling on the switch for the power seat and causing it would pull 6-7 amps and then it would shut off and pull 6-7 amps and shut off. And you could hear it clicking and trying to do stuff. Actually had it was an old Tornado. I haven't seen one of these things in years. But it had a power antenna that was trying to move over and over again. And I remember back in the day, those power antennas were a big deal. They were on a lot of vehicles and they would cause draws. But I could hear this thing in the trunk trying to do its thing over and over again. And of course it didn't function. It hadn't functioned in years. So we just unplugged it. But, sometimes that gets you to the draw really quickly just by an audio and a visual inspection of the inside of the vehicle or even outside of the vehicle, depending on what you're dealing with. All right. So for the actual testing, here's what I'm going to do. I'm going to start at the battery. Okay. I'm going to go to the battery and what I'm going to use is an inductive amp clamp. Now you can use a scope if you want to, nothing wrong with that. I like to just use the little Snicker bar sized amp clamps and I have 2 of them. You can get them $50 off Amazon. The jaws go around pretty much every battery cable and you can put them around a single strand of wire, no problem, but they'll fit around any battery cable that I've dealt with. And I just get a couple of these things. You really only need one, but I just have 2 of them to make my life easy. And what I'm going to do is determine at this point, what is the actual draw on the battery? What's the size that I'm dealing with? But I also want to determine what the direction of that draw is. So here's what I mean by that. I'm going to put these clamps or clamp around the cables leaving the battery. And I want to start at the battery and move outwards from there because that's the component that's being drawn on, of course. And I want to know, where is that current going from the battery? And of course that might sound obvious. Well, of course we're trying to find the draw, but I want some physical direction as to where that current is going once it leaves the battery. So here's what I mean by this. Imagine a positive battery cable and we have the battery, the terminal, and the cable leaving it. That cable is going to branch off into different sections, right? We're going to have like a main thick cable that goes to the engine, maybe the starter alternator, and then we'll have another cable that runs to the underhood fuse block, and then maybe a third cable that branches off to the interior fuse block, right? And this will all depend on vehicle application, and there's going to be a lot of different variation here, but you're going to have some sort of distribution of cables off of the battery. And I usually find the positive battery terminal is more helpful for me here, but you could use the negative as well and determine it this way. But what I like to do is I put my inductive amp clamp around the individual cables leaving the battery to determine where is this draw going, right? And this will also, it's going to inform me on the size of the draw that I'm dealing with, but is it going towards the engine, alternator, starter? I've seen alternators cause draws before. Is it going toward the underhood fuse block, or is it going towards the interior of the vehicle, right? And this can be a really quick check just by moving this clamp from a couple different cables. And once you've identified your draw, okay, let's say we have a 2 amp draw in the system. Well, now I'm just looking to see which cable off of the battery, where is that draw going to? Which physical location on the vehicle is that current going to from the battery? And this is so helpful to really determine some direction, because you can use this any place that you have battery cables or positive cables or even ground cables for some really quick direction. Again, this all depends on vehicle application and how they're set up electrically, but I've been at fuse distribution centers where it has several cables leaving it, and you can again quickly just put this clamp around all of the cables and find your direction relatively fast. This doesn't take a whole lot of effort to determine, okay, the draw is definitely coming from this distribution center under the hood or this distribution center under the dash. It's pretty efficient to tell you the direction you need to go to move you to your next step of testing. But here's the other thing about this is we haven't disconnected the battery. We haven't disturbed anything. This is non-intrusive. The car is still asleep. The car doesn't know you have an inductive amp clamp around these cables, and so it's not going to wake up from doing this test, right? And that's where disconnecting a battery can be tricky because we're changing things about the system. We're opening up the system or disturbing things, which I'd rather not do in this case, especially if I've waited close to an hour for it to go to sleep. All right. So now this hopefully gets me to the distribution center or the area of the vehicle where my draw is coming from. And a lot of times you end up finding that this is a fuse box or distribution center of some sort. That's where your draw is coming from. Okay. Well, now I can do some specific testing at those fuses or at this component in order to pinpoint exactly where my draw is coming from. So there's a second tool here, and I'll put the links to these tools in the show notes as well. There's a second tool here that's really helpful. It's called the amp hound. Okay. And this has been around for quite a while. The one I bought when I was still a tech at Firestone. And you can use a voltmeter in place of this. Really what this tool does is it measures the voltage drop across the fuses, and then it correlates it to an amperage measurement depending on the size of the fuse. Well, you can do this just with a voltmeter and through a chart online that's pretty easy to find. Again, I'll put the link to the show notes. And basically the theory is there's current flowing through a fuse. There will be some voltage drop across the fuse. It will be a small amount of draw, but it will be measurable, and you can correlate it to the amount of current moving through that circuit, again, based off the size of the fuse. So what I do is I take my amp hound and I set it up for the correct fuse size, and I'm going to check all of the fuses in this distribution center to see if I can match the draw that I see on my inductive clamp to the draw that I measure on my amp hound, right? And what I'm hoping to find is an individual fuse that correlates to the draw that I have coming out of that battery. And if I do, I'm usually pretty much there, because then I follow that fuse to the component and figure out, okay, why is this component on or drawing current, right? And I could also at that point pull that fuse to verify that it removes the draw. But that's usually pretty straightforward if I can find that. Now, I will say this only works with fuses that have exposed terminals, right? So if you think of a fuse, you could poke the top of it with a test light or a meter, and we're doing that with the amp hound or with our voltmeter. There are some fuses that don't allow for that. There's also things like circuit breakers and relays and modules themselves that don't apply themselves towards this method of testing. So if you're lucky, this is it. You found your draw at this point. You found your fuse. Okay. That fuse directly feeds the radio, and the radio's staying on and needs to be replaced. And that would be great. But for whatever reason, that never seems to be the case for me, or very rarely seems to be the case for me. So I'm going to go through a few other things that can happen when you get to this point and you don't have any direction necessarily. Now, if you didn't find any fuses that had a significant amount of draw, and you're going to find some that have a little, right? There are certain systems that have a memory draw that's very, very small, but it doesn't equal the troublesome draw that we're trying to chase. But what do we do if we know based off the inductive clamp that our amperage draw is going to this distribution center, but none of our measurable fuses showed us our draw that we're looking for? What are the possibilities here? Well, that distribution center could be a module, and it could be drawing the power, or we could have a different style of fuse, one with like a little plastic cover over the top, or a fuse that's maybe not accessible, right? If you think of like a bus bar style, Toyota has some of these where you really can't even access the metallic portion of the fuse to do measurements. It could be a relay, could be a circuit breaker. There's a number of things that the amp hound is not going to measure, a voltmeter is not going to measure. Okay. What do we do at that point? One thing you can try, and this goes back to why I may have a vehicle put in a cool location, meaning not sitting out in the sun, is you can try a thermal imager at this point. And you could actually start your diagnosis with this as well if you wanted to. Again, this all goes back to what size draw am I dealing with? Because if it's below a half an amp, I have not had good luck with the thermal imager. If it's above a half an amp, I have had some luck with the thermal imager. And this is where something like a fuse or a relay that's drawing enough current will show up as a hotter component than the rest of that fuse box. Of course, if the vehicle's been sitting out in the sun for a decent period of time, this is not going to work for you. The colder the vehicle prior to doing the check, the better. So in Minnesota in the winter, it makes it easy, but I realize we've got lots of hot parts of the country where if this thing's sitting out in the sun, even if it is a couple amp draw, I don't know that you'd be able to find it with a thermal imager. So you may have to set up the vehicle in a cool location in order to do this. But thermal imager is an option here. And a lot of those fuses that you can't measure, the ones with the plastic top, they are the higher amperage. And so again, goes back to what size draw are we dealing with. But if it's a higher amperage draw going through one of those big fuses, you might be able to spot it because the current moving through the circuit is going to develop some heat and change the temperature as compared to the rest. So that's an option. Of course, you could always do the pulling of fuses that you're not able to measure or relays you're not able to measure at this point. I really try to save this for last though, because the whole reason I'm using the amp hound or voltmeter is so I'm not disturbing the system and I'm not waking stuff up. And you can wake stuff up by unplugging fuses. So I really save this as a last resort. Okay. I've measured everything I can. I know there's a draw coming out of here, but I can't measure it across these fuses. Okay. Then that might be a point where I'm disconnecting or unplugging stuff just to try to see what happens, but do be careful with that because you can wake up the system, reset the whole process and waste time, which we want to avoid as much as possible. All right. Now I'm going to give you another scenario here. And this is one of the scenarios that I run into on a regular basis at shops after they've tried to make the diagnosis, maybe replace the component. What if you have multiple fuses in this distribution center that all have smaller draws? They're noticeable enough. Maybe it's a quarter of an amp here, a third of an amp here, half of an amp there. But this is on multiple different fuses in the same distribution center. And if you add them all up, they add up to your total draw. But this is going across multiple fuses. What do we do with this? And this is where shops will usually replace a body control module or a instrument cluster in order to fix the draw. Now, are they following the same process that I am exactly? Probably not. But what they are able to surmise is that there is a module, usually a body control module or a cluster in a Chrysler vehicle, that when they unplug it, because this is their method, is they go around, they unplug stuff until the draw goes away. When they unplug it, the draw goes away. And so hence that component that was unplugged, that has to be the cause of the draw. Let's replace that. So this is why I reprogram a lot of body control modules. And again, clusters and Chryslers is because they've identified, well, if I unplug this, it kills the draw. And I'm sure it does. I believe that that is the case. The problem is the body control module or the cluster, which kind of is a body control module in a lot of Chrysler vehicles, is going to provide power to a number of different things in the vehicle, if not all of the things in the vehicle. And so when you unplug it, of course it's going to kill the draw because you've cut power to all kinds of things in the car. But after that BCM, that body control module, is replaced and programmed, there's still a draw because that module was just doing what it was supposed to by powering up other systems. The reason that those systems were awake, there's something else that we have to deal with here. Okay. So going back to what if we find multiple fuses that have current draw on them? What do we do with that? How do we approach that? Well, at this point, if I see that, the first thing I'm doing is grabbing my scope and I am seeing if the vehicle network or networks are awake and talking, right? So what I mean by that is I'm just going to maybe, depending on the application, go right to my DLC or access the vehicle network somewhere, and I'm going to tie into it with my scope. And after this thing is powered down, hopefully I'm still in that state, I just want to see, is there activity on the vehicle network? Okay, this could be a CAN bus, this could be a class 2 data network, it could be a LIN bus, it depends on the vehicle configuration. I just want to see, are people talking? Are the modules trying to communicate when this thing's powered down? Because if they are, that means the whole network is awake. Multiple modules are awake. They have not gone to sleep yet because someone is still talking on that network, keeping the modules awake. And they all are going to have a small amount of draw, maybe a quarter of an amp, maybe half an amp, and it's all going to add up to a draw that kills the battery overnight, maybe over a couple days. From what I've seen, personal experience, when you have a network of modules that are awake on a modern vehicle, you will have a 2 to 3 amp draw consistently. And this is across brands too. This is BMW, Chrysler, GM. I've seen this on all of them, where a network that is awake and talking will cause a 2 to 3 amp overall draw. So we're measuring right from the battery. It's pulling 2 to 3 amps out of the system. Multiple modules are they're all adding up to this draw that's killing the battery. Okay. Now, just getting to the point where you can identify that this is the problem, that the network's awake, is a big step, because now we have a totally different thought process towards this rather than one single component drawing down power on that battery. Well, we've got a group of components that are awake. Now the question is why? But how do we do this now? Maybe we've identified the network that is awake. Maybe there's multiple networks, but what I want to do is I want to get a diagram or a topology of how the network is set up on that particular vehicle. And I want to develop a plan to divide that network and start testing, right? So if I can split that network in half on the vehicle by unplugging a connector, or maybe finding a splice pack on GM vehicles, and I can separate that network into different sections, or like I said, divide it in half and use my scope. Scope's critical here because you can see the activity. You can see who is talking, right? Who just won't shut up regardless of the fact that you've turned the key off. And having a network diagram in front of you is critical here, but we're going to divide that network at a certain point and then start doing some testing to see what leg of the network is still talking once I've split it in half. Am I going east or am I going west with this? And you're going to divide that network down into smaller and smaller sections until you find the leg or the module that is still talking when he's not supposed to. They're still putting messages out on the bus, because that will keep everybody else talking as well and keep drawing on the battery. And this is one of the most common reasons that modules are replaced when they don't need to be for parasitic draws, is a network that is staying awake. Okay. So again, the divide and conquer method, which again, I learned at training, is a really effective way to zero in on who is staying awake and who's talking. Okay, so find those connectors, find those splice packs, find those points where you can divide up the whole, because it's a whole vehicle, right? It runs the length of the entire vehicle. How do we separate this out? How do we divide this out into sections? A diagram's key in order to do that. Okay, let's say we found our module that is talking, that is keeping everybody awake. And we take him off the network and everything goes to sleep and the draw goes away. Awesome. Do we just replace that module? The answer is definitely no. Maybe it might be the module that needs to be replaced. But the last thing that I want to look at is there any inputs to this module, any switches, any circuits that could be keeping this module awake for whatever reason? And that can happen, right? I mentioned a BMW. It was well, probably a couple of years ago now, actually, that I had a parasitic draw on because there was a piece of cardboard wedged under one of the window switches, which was an input to a module that was keeping it awake. I had a Chrysler, a Dodge Journey that the horn switch was shorted and it was keeping the cluster awake. It was an input to the cluster and it was not going to let it go to sleep. I've had other examples like that too, where switches and inputs to modules cause them to stay awake and cause them to have the network talk and to cause a draw in the system. All right, so we want to look at a diagram. We want to maybe scan this module at this point with a scan tool to see, is there anything that looks out of place, any inputs that this module could be getting that is causing it to stay awake that a replacement module ain't going to fix. You're going to have to fix, whatever input is going into that module. That's a possibility as well. Okay, so that's it for my tips and procedure on a parasitic draw. And again, some of the things I've been seeing recently, so I wanted to just put this out there. So hopefully this will help somebody out if you got a battery that's draining on a vehicle. But other than that, I'd like to thank everybody for listening. Thank you for all the feedback. Definitely appreciate it. Keep that up. But let's all get out there and start fixing the world one car at a time.
Yeah.